Welcome everyone and thanks for watching. My name is Jim Barry and I'm a solution engineer on Esri's transportation team. If you have any questions or comments about what we're going to cover today, feel free to follow me on Twitter or shoot me an email and I'll do what I can to help. For the next 30 minutes, I'm going to get you started with ArcGIS tools on the web that you can get your hands on now and resources for you to get productive with them quickly. I've got a lot of information for you, so feel free to use these slides as a reference as you go forward. I've included a tiny CC URL that will link you to the current version of these slides and this video with the most up-to-date information. If you don't have 30 minutes handy and you need to get started right away, here's a URL to a cheat sheet which gives you everything you need to get this stuff into your hands and get mapping. It has links for how to sign up for a free license, explore what ArcGIS can do, and various ways of getting started, importing data, making and styling maps, and building custom apps around your maps and tools. If you're a developer, we have APIs for you. And if you're not, we have lots of apps, app builders, templates, and other resources for building customized maps and apps without code. First, about us. We are Esri. Founded in 1969, we're the world leader in Geographic Information Systems technology, often called GIS. These are tools for managing spatial data, analyzing it using geospatial science, and visualizing those results in various ways, most often on a map. In short, everyone at Esri are true believers in what this technology can do and has done to improve our relationship with our world, using resources efficiently, and improving the lives of people by understanding our world and our impact on it. If you want, you can learn more about what Esri does and why we've been doing it for over 50 years here at Esri.com. First, what are we going to learn? Well, we're going to learn what ArcGIS is, then we're going to get you a free license and put it all into your hands. Next, I'm going to walk you through some of the basic skills, following a data design develop pattern, how to get data in, how to make and style an effective map, how to use some analysis tools available on the cloud, and how to share your maps and tools with others, with and without code. In short, ArcGIS is a comprehensive set of apps and tools for managing, analyzing, and visualizing spatial data. But it's a lot more than just putting your dots on a map. You can model your world in 2D, 3D, detect patterns, and make effective decisions. You can also use modern innovative technologies such as AR/VR, game engines, artificial intelligence, live streaming data, and then use a wide variety of ways to get your maps and tools into the field using customizable apps, dashboards, story maps, to anyone, anywhere, anytime on any device. Now, I don't want to get too far down the rabbit hole here, but ArcGIS does offer heavy-duty desktop workstations and enterprise-class server software. But what we're going to use today are the lighter weight, easier to use options. Basically, WebGIS, where everything's running in the browser, or on the Esri Cloud's PaaS, or Platform as a Service system. The diagram here in the upper right pretty much sketches it out. Here at the bottom, on the server, or on the cloud, is the spatial data you'll be mapping, and the functional tools for working with it. Then here at the top are the wide variety of devices you can push those maps and tools to. Then here in the middle is a portal tier that you can use to manage that content, manage security, and manage users and groups, controlling who can access your content if you want. Here's a quick snapshot of some of the capabilities that you can bring into your apps using ArcGIS. Many of you might be familiar with finding addresses, routing shortest paths, and visualizing your maps in 2D and 3D. But ArcGIS also provides the ability to host your services in the cloud and provides hundreds of thousands of useful data sets that you can include into your apps as well. And then, of course, the special sauce of GIS, spatial analysis and data science. All of these are accessible through an engineered set of apps and tools designed to work together and make these capabilities as easy as possible for you to access. Whether or not you consider yourself a developer, for our purposes today, developers.arcgis.com is the website you'll use to access all this stuff. While we have a full set of APIs for the web, for native app development, for REST, and for Python, We also have app builders and templates and open source projects that you can download and use for building pretty customized stuff, even without code. So, are you ready to go? Okay, let's get signed up. On the developer website, you can create an account by authenticating using one of these other systems, or just enter your name and email address and we'll activate your license and portal on the Esri cloud that you can use for web hosting and cloud-based geoprocessing. The key to getting started quickly are a set of tutorials that you can run through in just a few minutes. When you have your account and you're logged in, on the front page of the ArcGIS Developers website, click Learn and Get Started Building link, as shown here, and this is where we'll start. While there are over 100 tutorials here, you're only going to need to go through 3 or 4 of them to get productive. Each one takes about 10 to 15 minutes to go through, hands-on, and for each, there is a View It in CodePen link that brings you to the result. If you're a coder, right here you'll find a few tutorials to get you going. First, a Hello World style sample to get an interactive map into your page, and then 2 more to show a couple of basic location services. In this case, searching for an address anywhere in the world and finding a shortest route with directions. We'll get back to those coding samples here in a bit. Before you can build an app, you need to create a map. And before you can create a map, you need to figure out where the data is. All across the web are open data portals and commercial data vendors that have lots of data that you can use. Often finding it is as easy as doing a basic web search. I tend to use terms like GIS, map, data, download, followed by other keywords of what I'm looking for, like bike lanes, tree surveys, water samples, weather data, or whatever I happen to be searching for. In addition, your ArcGIS license gives you access to the Esri Living Atlas of the World, where you can search the globe for useful, up-to-date data ready to use with your GIS. Another great source of data is the ArcGIS Hub website. Government agencies from all over the world use the ArcGIS Hub as an open data portal. Here, I searched for Get Food NYC distribution locations across New York City, established to help deal with the COVID-19 public health crisis. Once I find the data I'm looking for, you'll find that often this data is already published as web services, and you can bring it right into your web map as is. Or you might find that some data sets are just sitting on a data portal or FTP site, and you need to download it in one of a variety of formats before publishing up as web services yourself. And I'm about to show you how to do that. This Get Food dataset happens to already be published as a web service. So what I do is grab the REST endpoint URI, which is really just a URL, and I copy that to my clipboard. Then in my web map, I paste the URL in, and boom, there's a layer of Get Food location points. I can even click on a point to learn more about it. I'd like to show you how you can do this yourself. When the data you want to use is already a web service, that's best. But sometimes the data you need is sitting on a server disk somewhere, in which case you need to download it first, then publish it up as a web service yourself before you can make a web map and web app out of it. Listed here are several of the most common data formats you might find out there, and ArcGIS is ready to import any of them. Shapefiles, GeoJSON, and CSVs are 3 of the most common formats, but you may run into some of these others also. So with that in mind, the first tutorial I'd like to have you start with is called Import Data as a Feature Layer. So back to the tutorials page, find the one called Import Data as a Feature Layer, and you'll find a short 10-minute hands-on exercise. Follow the steps, and you'll create 3 hosted feature layer web services ready for mapping. In fact, what I'm going to do here on this video is I'm going to run through these steps here with you first, then send you on your way to give it a go yourself. First, log in with your new account, and you're given a link to download the sample datasets. What you end up with are 3 datasets: a shapefile of parks as polygons, a GeoJSON file of trails as polylines, and a CSV file of trailheads as points. That way you get to work with 3 different formats, And you also get to work with the 3 basic feature class types in a GIS. Just as a side note, a vector-based GIS starts with the premise that everything in the world can be modeled as either a point, a polyline, or a polygon. Points might be light poles, fire hydrants, and street signs. Polylines could be street center lines, streams and rivers, and water pipes. Polygons could be land parcels, building footprints, and city boundaries. At that point, once we've digitized the world this way, then the spatial analysis that GIS provides is just math and geometry. It's computational geometry, actually. That's what gives us speed and accuracy. Okay, back on track. From your dashboard on the Layers tab is an Import Data button. The tutorial asks you to drag and drop the parks shapefile, which is in a zip format, onto this new layer page. Then you get to set some other properties on this layer. In this case, we'll just go ahead and take the defaults. Then what happens is the shapefile is uploaded from your disk into the Esri cloud, and a web service is created from it. We call this a hosted feature layer. There above is a web service URL, or REST endpoint. As a shortcut, you can click to open your new layer in a 2D or 3D map. Or you can use this web service URL to bring the new layer into your map. And here's what it looks like. This web map starts with a base map layer of topography, and then on top of that base map is the new layer of parks that you just imported. Each park is drawn as a blue polygon. If you follow the tutorial just a few more steps, it'll have you import the trails and then the trailheads. Now all 3 imported layers are in the map. They don't look all that great right now, but next we'll go into how to style the map to make it look better. If you don't have the data that you want to map, sometimes you have to go out into the field and collect that data yourself. Well, ArcGIS provides a couple of mobile apps that you can run on a tablet or on a smartphone, using the GPS built into that device to collect yourself or crowdsource the data that you want to map. Now let's make a web map from existing web services that don't need to be imported first. From the documentation area of the developer website, find the Create a Web Map tutorial. It takes about 10 minutes to do. It's step by step. But if you want, you can click the View Solution link to see the finished product. Here in this tutorial, you're given 4 REST endpoint URLs, and one at a time you add them to the map using the Add Layer from Web menu item. Here on the right, if you want, you can even swap out the base map layer. You have lots of choices. Esri provides a few, like a streets layer, a topographic map, subdued light gray and dark gray base maps, as well as satellite imagery, and OpenStreetMap as an option. Whatever serves your map the best. In the end, you end up with a similar map, a topographic base map, and layers for parks, trails, and trailheads. Click on any of those features and a pop-up shows you more information about each. Now let's make your map more useful by styling it in a way that shows some of this information more intuitively. Here's the next tutorial I'd like you to do. It gives you a step-by-step process for applying what we call attribute-based symbology to the features in the map layers in order to make them more useful. Or, if you want to see the end result right away, click View it live. You might have noticed that by default, each trailhead is a small circle, perhaps a green or maybe orange dot. But regardless, this tutorial shows you how to apply a more useful point marker. In this case, why not change each circle to a little graphic that looks like a hiking sign? And now each trailhead point is given a hiking sign marker. This is one small way of making your map more intuitively useful. Next, the tutorial has you apply some symbology to the line layer of trails. Each trail polyline is associated with a record in the layer's attribute table. One of those is a value that represents the number of feet of elevation gain there is along that line. ArcGIS lets you apply a rule so that trails that are very steep up or down are given a thick line, and trails that are relatively flat are automatically given a thin line. This makes the map even more useful. If I'm hiking or biking and want to challenge myself with steep trails, I can find those pretty quickly just by looking for thicker lines on the map. Or I can stick to the flat trails of the thin lines. Very easy for whoever's using your map. Now let's apply a rule to the parks layer. There are different kinds of parks, and each park has different rules for going there. Some parks I can just show up, or some I might need a pass or a permit. Some trails I can hike on but don't allow bikes. So let's apply a rule that helps using a column in the parks layer called type, as in the type of park. ArcGIS scans through the feature layers table, and for each polygon it draws, it chooses a color based on the rule that you gave it. Here you can see natural areas in purple, regional open space in green, local parks in blue, and so on. You can change these colors if you want, or just take the defaults. That's up to you. If I click on one of the trailheads, a pop-up opens with more information about that trailhead. The default pop-up is a bit rough. There's really no styling here, and it uses the actual database column names, which are sometimes a bit cryptic and aren't very easy for the general public to use. ArcGIS gives you the ability to customize the pop-up a bit, telling it which columns are visible to the end user and which don't need to be seen, which values are editable, and some other settings. Now you can see the field names are much more intuitive. More advanced is the idea that the pop-up can be used with its own tabular grid type appearance, or choose a different appearance. And even if you're a designer, there's some limited HTML and CSS that's supported to make it look even nicer. You can even display images and charts in the pop-up as well. Now that you've published your data as layers and designed them into a map, let's look at the variety of ways you can share your work. When you're in the map viewer, there's a share button that you can use to control access to your map. By default, all work is private and only you can see it, but you can also share it to a defined group of people or to everyone in your organization, or even share it on the open internet with anyone in the world. There's also some social media links and a special ArcGIS URL shortener. If you're creating your own web page, or you're perhaps writing your own blog article, you can configure an iframe HTML tag here that ArcGIS gives you, that you can then copy paste into your page in order to embed a live interactive view of your map into that page. There's also a button for wrapping a custom web application around your map. There's a couple of dozen configurable web app templates that ArcGIS will create for you. Then you can share your map as a web application. Elevation Profile is one of the many templates you can choose from. This one seems appropriate for us since we've been working with data related to parks and trails. Here's what that configurable app template looks like when it wraps around my map. When I choose a trail, it makes a REST call to an Elevation Profile web service that converts that trail line into a sideways elevation profile. So if I'm going to hike or bike on this trail, this is a really neat way to see the hills that are in my near future. This is now a very useful, yet still very simple web application. ArcGIS gives you several other ways to create some really customized web app experiences, most of them without having to write any code. This helps get your maps and tools out there most quickly. Web App Builder and Experience Builder are widget-driven apps that run right in your browser, that walk you through building robust web apps that sometimes only take a few minutes to create. Story maps are another great way to get your maps out, not just relying on your end users to understand from the map what you hope they'll understand, but when you can tell your own stories along with your maps, you can communicate more effectively. Dashboards are another very popular way to create a web app that helps consume volumes of information in a digestible, easily understandable way. For example, here's a dashboard you may have seen recently. Johns Hopkins University used ArcGIS to visualize the volumes of public health data in an easily understandable way. At a glance, you can see the current state of things as well as trends over time. What you do is you bring your map into the dashboard, then you use this menu list of elements that you can drag in, resize, and connect data feeds and action triggers to. Web AppBuilder lets you bring in your map, choose a theme, colors, and labels for your web page, and also choose from several dozen widgets to give your end users only those tools that you want them to have. That way they can get to work and not spend time trying to learn how your app works. In fact, you designed it for them, for what they need to do. Here you can preview what your app is going to look like on a variety of devices. That way you have time to adjust things like line thicknesses and label sizes and tool widget locations before you send your app out into the field. Web App Builder has responsive design automatically built in so that the app that you build will look great, whether you're on a large desktop monitor or on a tablet or on a small smartphone, in portrait or in landscape mode. AppStudio is codeless, template-based way to create custom native apps for your maps and tools. For Windows, Apple devices, Linux, Android devices, and more. What you do is you build your app once and then compile it cross-platform, deploying within your organization or sell your app on the various app stores. Okay, developers, get ready. Sure, there's a lot of no-code ways to build custom apps, but developers often want the API. Where's the API? They want to code things themselves. Okay, so let's do that. When you're logged into your developer account, you'll see a wide variety of APIs that you can use depending on what kind of app you're building. The REST API is one of these. Most of our APIs, whether they be for the web or for native devices, wrap around or are based on our core WebGIS API, called the REST API. Even if you're using one of those other more specific APIs, you'll always have the ability to make lower level calls to web services directly using the REST API. For example, here's a short list of some of the location services exposed by the REST API. While ArcGIS offers more robust APIs for a variety of platforms, sometimes you don't actually need a physical map, or you don't need or don't want to load any libraries. Sometimes you just need to make a simple REST call. Like here. Here we're using Postman to test a simple HTTPS GET request to Esri's World Routing Solver to get some JSON in return. What we do is we pass in 2 point locations as our stops as the URL parameters to a routing service. That service finds the shortest path, then returns to us some JSON containing all kinds of information that we can use. The geometry of the path, locations, distances, turn-by-turn directions, and more. What you do is you parse out of the JSON the information you want and you move on. If you're a web developer, while we have a JavaScript API that wraps around the REST API to some degree, and I'll get back to that in a moment, we also have an open source JavaScript library which makes the REST API easier to use. For example, here's the documentation and tutorial for how to make that same shortest path route request that I just made on the previous slide, but from this REST JS API. Here's some code from the short tutorial that shows how to use this REST JS JavaScript library in your apps to call a wide variety of content and location services. This one, again, being routing. See here, I reference the libraries that we provide along with their API key. We make an asynchronous promise call to the API's solve route method. And on return, we parse out the return JSON and do whatever we want with it. But how about a robust JavaScript API? You bet. The ArcGIS API for JavaScript is the most popular, most used API amongst our global developer community. It's as easy to learn as it is robust. There are a few dozen tutorials, and all of them can be used standalone in CodePen, or you can copy-paste them out into your web development environment. Our API supports the use of TypeScript, and is also currently being used along with all of the popular web frameworks, both older ones like Dojo and jQuery, but also newer ones like React and Angular. The JavaScript API page on the ArcGIS Developer website has hundreds of runnable code samples that you can learn from or cobble together. Each sample can dump out to CodePen so that you can work with it there or to modify it and see its behavior before pasting it into your development code base. For example, here's a line of sight widget that works in 3D scene view maps. With it, you can analyze whether or not various points on the ground can be seen from some vantage point, or vice versa. The sample code in CodePen lets you try out the widget before pulling it into your code base. If you're already using one of these web APIs, you can still use location services from Esri and plug those in. You don't need to start over with our API. We have lots of sample code that you can paste and run with. Just insert your API key and go. For example, here's a Mapbox.js based app. What you're seeing here is a Mapbox map component, Mapbox tiles, and a pop-up. But within the pop-up is data that comes from Esri's reverse geocoding service. This is just a quick hello world type approach to pulling Esri location services into other map technologies and open source tools. The way to access location services from Esri, regardless of which development tools you use, is to create an API key for yourself. Add that key to your code, and those services light up. Well, that's great if you're doing web development, but how about native apps? ArcGIS comes with a set of runtime SDKs for .NET, Android, Java, iOS, and Qt. All of these SDKs are based on a C++ core that provide all of the functionality, and then we build SDKs around it so that these capabilities fit into the conventions of each type of development. Each runtime SDK has a half dozen or so tutorials that you can bring right into your IDE, like Xcode, Eclipse, Visual Studio, Qt Creator. Also, there's a growing list of open source projects for runtime apps that you can bring in, compile as is, or extend further. They're a great starting point. If you're a data scientist using Python, ArcGIS provides Python packages for connecting GIS capabilities to the work and analytical projects that you do. Same as the other APIs, there are quick tutorials for getting started to help learn some common tasks like creating map layers, creating and sharing maps, performing statistical analysis, and accessing location services such as routing and finding addresses and places. Each of the tutorials load up into Jupyter notebooks to make things interactive and easy. Or you can bring the samples into other Python dev tools such as PyCharm, Spider, and more. And when you want to start adding GIS to data science, there's a growing list of sample notebooks, some of them shown here. Analysts find these sample notebooks very useful as they learn some best practices for using GIS in data science. The ArcGIS API for Python also includes modules that wrap up some popular AI capabilities for machine learning, deep learning, and more. Here are some examples of doing feature detection on images and video using deep learning. On the left, detecting vehicles and pedestrians, and on the right, we're using deep learning to count and categorize the number and type of rail cars as trains arrive and depart from a maritime port. All we need to do is train a deep learning model, teaching it what a locomotive looks like or what a boxcar looks like, a flat car with shipping containers, and so on. And that fully automates something that it used to take people to do. The global Esri user community are hundreds of thousands of skilled people learning and helping each other on the Esri Online community website. There are a couple of hundred topical community areas that you can learn from and help others. As you are learning ArcGIS, there's a very good chance that any issues you run into, someone else already has, and through community voting, the best answers have already bubbled to the top. The global Esri developer community also contribute to the hundreds of open source projects built on the ArcGIS platform. It's not just apps, but you can also find samples, libraries, templates, tools, add-ins, and more. Once again, here's a URL to this slide deck and to the cheat sheet document and this video. As you use ArcGIS, best of luck to you. Please let us know how things go. We're really excited to see what you build with it. And please contact us if you have any questions, comments, or in any way else think that we can help. Thank you for your time.